Hello everyone, my name is Johnny Berganyo and I'm going to present my final project for Visual Analytics, which is production yield review with decision support system. So as I go along, I will course through to the following topic, which is the introduction, problematic situation, description of the situation, list of things to look for in the SSD, support case in decision making, the main task and the overview of the system, and then lastly the summary and conclusion. For the introduction, Skyworks is a high-performance semiconductor manufacturer that provides the technology to enable connectivity for critical industries, from telecoms to aerospace and automotive. Skyworks is always operating into the future to ensure it is ready to meet the needs of its customer and the world they connect as they constantly evolve. It is increasing its investment in new and emerging technologies such as 5G and driving excellence in its manufacturing engineering processes to enable faster speed to market through automation. So the applications and infrastructure that power these processes are built in a very complex multi-cloud and hybrid technology environment. Skyworks has a footprint in every major cloud services platform as well as its own on-premises data centers, which makes it difficult to obtain an end-to-end and view across its applications. For the problematic situation, so as a company, customer satisfaction is the main goal. Delivery and quality are the main elements to meet this requirement. So in order to meet these requirements, review of yield and defects are performed on a daily basis in order to improve production line performance. So data are retrieved from different sources, servers, and are cross-referenced. These processed data are summarized in pivot tables and charts. Then these tables and charts are being analyzed, interpreted, and reported to the management. Decisions are made based on the presented data. The proposal is to design a tool that would automatically process this data and be able to provide information regarding yield, ppm of defects, and provide Paretos in a daily, weekly, monthly, and quarterly basis. So for the description of the situation, so we have these five steps, where in the first step is the extraction of data from the system to current day. Step two is process the extracted data. Step three, analyze production performance. Step four, provide Pareto of the data. And then lastly, the provide solution. List of things to look for in the SSD. So we have the yield of the product, ppm of defects by product. We need to look for the cost of rejected devices also, Pareto of defects by product, and Pareto of defects by machine. And these are the needed information in order to make decisions for the management in which issue or item they should prioritize in order to improve the production line performance. For the support case in decision making, these are the things that we needed to have products with, or we needed to consider products with highest load, yield in quarterly, monthly, and weekly, or maybe daily basis, defects with high ppm level, products affected by defect with high ppm, machine where these affected products were processed, cost of rejected units. So this is the dimensional data of the model design, wherein we have the fact, which is the data, and the different dimension that compose the data, which is the part number, lot number, defects, and then the different process process step in the production line, which is watering, cavitation, AOI, femto tray, singulation, and QAS, AMSA assembly. So the main task is to design a visual analytics system that supports management in making the best decisions, to which line issues to focus on based on the product cost, defects, PPM level, and volume. So here is the overview of the system. So here is the actual model of the data where we have the data for the output, the defect, cost of every unit, defect, and then the area where it was processed, and we have this improvement value, which is an additional item wherein I can validate how much will be the savings if I will improve my process by a certain percentage. And this is the goal value. We have the process field, and then the rest of the table are the information in every process. This page shows the quarterly yield trend, monthly yield trend, and the weekly yield trend. And at the bottom of the screen, we have the meta slider wherein I can adjust the meta or the goal of the yield. And I have the slicer for the year, quarter, and the month. I also have the part number wherein you can validate the yield trend of based on different part numbers. So I'm going to adjust or select the year and the first quarter and to view the actual performance. This is the overall performance. So as you can see, the monthly yield is going up, and then we have the weekly yield wherein in week 5 and week 6 it went below the set meta of which is 99.75%. And then also this meta can be adjusted based on the requirement. Okay, I'm going to the next page wherein we're going to discuss the PPM trend based on the performance of the line. So as you can see here, we can validate on week 9 which which defect have caused this uh, low yield. So I'm going to set the slicer the year to year 2025 quarter 1, and then I'm going to select week 9. I'm going to remove the filter. So as you can see here, we have a lot of defect that caused the low performance on week 9. We have the code 90 defects 71 and 93. So if I'm going to select the code 90 and then review the performance. So we have the PPM trend from February to March. It was increasing from work week 8 until work week 10. It was linear, and then it went up this work week 11. And then on the right side of the screen is where I can set the improvement based on how much percentage I can lower the defect and the equivalent improvement savings. So let's say I'm going to apply 20% improvement, and it will show me 35 the amount of the savings that I can have based on this data. On the next page, I'm going to discuss is like a more deeper analysis of the defect wherein I can validate in which machine the code 90 on which machine those slots were processed. In this page is in singulation process where we have different machines with high high rejection level, which is HANMI 55 and HANMI 50. And the most affected part number based on the Pareto is this 58440 device. So on the right side is the list of lots that were processed on this machine with those rejection of code 90. If I'm going to select the HAMI 55, it will show me all the list of lots that have the code 90 defect. I'm sorry. On the next on the next process, which is the sputtering, it has the same um, configuration. I have here the code 90, and it will show me this Pareto of machines that have processed the lots that has high rejection of code 90. So for example, the Axela 2, and these are the list of lots. And this is the part number that is mostly affected, which is also the same, the 58440. Next is 58455, so on and so forth. So this is for the film to tray. We have film to tray 51, and then for the AOI, we have this ICOS 11 and ICOS 13. So as you can see here, the list of the lots. So that's the overall overview of the system that was created for the in order to help the management focus on which defect and which area they should look onto in order to improve the performance of the line. So on the next pages are the screenshots of the sample screenshot of the system, which shows different scenarios. So in summary, the system was able to provide information of the yield performance in quarterly, monthly, and weekly basis. And then PPM trend of defects were also provided with cost of rejected devices that can be also viewed in quarterly, monthly, and weekly basis. Pareto of defects and products in terms of PPM is also available, including the cost of the units, giving the management at their situation which defects should be prioritized in terms of PPM and cost. Pareto of defects by machine in every process steps were also shown in the developed tool, identifying the potential contributor of the problem. So in conclusion, based on the performance of the developed TSS tool, it was able to provide clear information on which issue the management should look onto and prioritize. It also helped identify which machines in each process steps causes the defective devices. And that's all. Thank you very much.